Welcome to my presentation on the snow crew forecast data. For this assignment, I started with a snowfall data set that was available online that showed the average snowfall, or the exact snowfall, I should say, within any given day from 2010. As you can see, it shows essentially every day, even days where it would never snow, such as July and August. It shows every single day from 2010 to current. Obviously, we only have January and February for data sets here. And using this data, I first turned it into a table to give me a little bit more functionality with grabbing the exact data sets I wanted. I then copy and pasted the information I wanted. In this case, it would be every single available day that was recorded with snowfall for each specific month. So in this case, it'd be November, and I went 5 years out just to keep the data set at a reasonable size and at a reasonable and at a, shall I say, more recent. So within 5 years, the snowfall is going to be a little bit more recent versus 10 years ago. So moving forward, the probabilities given here shows the percent chance of it snowing these specific amounts. So in this case, it'd be 0, so no snow at all. This number indicates the probability of it not snowing whatsoever. So within any given day within November, there's a 79% chance, we'll say 80% chance that it doesn't snow whatsoever. And the way I calculated this was with a COUNTIF function, only counting days that are 0, divided by a COUNTA function, counting every single day within the data set. I needed to use COUNTIFs functions on the data sets where I needed a range, so between 0.01 inches and, in this case, it would be 1.1 inches, or basically a tenth of an inch. So this shows the probability of it snowing within any specific amount of the data set. And these sum functions show the accuracy of the information. In this case, I captured about 99% of the data within the data sets I was able to copy and paste. And the reason these aren't 100% in all of these is within the original data set I had here, along with snowfall data of specific measurements, there was also a trace amount data here, which essentially meant that the snow was coming down but was too little to accurately measure. So they put in a T for trace in this case, and with that I had to remove all of those variables, kind of reducing my overall days by a few per month. So as you can see, I've done this probability for every single month of my data set. In this case, I went from November, January, February, March, April. I calculated May, but with the data set I had, there was essentially no snowfall within May. As you can see here, basically a 100% chance that it's not going to snow in May. So for this reason, I decided to discontinue the May data set going forward with my other calculations. Once I got the probabilities for it snowing within each specific month, I moved through a distribution to better understand what the data looked like and how I would run a simulation with it. So in this case here, I have rough histograms of the snowfall data for each month that I moved forward with. So that would be November through April. And all of these data sets show a trajectory of essentially an exponential distribution. And I ran an exponential distribution originally with the November data set, but found the numbers to be unrealistic, as it had it snowing every single day. and it was a little unruly to work with, so I decided to go with a custom discrete distribution to run for every single month of the data I collected. So what you're looking at here for November is the probability of snow, probability of it snowing. So in this case, it would be a 79% chance of it not snowing whatsoever, a 5% chance of it snowing 1/10 of an inch, 8% chance of it snowing 35 or 0.35 inches, and so on and so on. The reason I went with these whole numbers is to better aid in data visualization, so it's easier to understand the data we're looking at, as well as the ease of use with the cost function I ran here. So for each individual trial, as you can see, I ran 1,000 trials for November as well as December and the rest of my data sets. I ran a VLOOKUP function with a random variable to give me a probability of it snowing accurate to whatever month I captured data for. From there, I ran an ifs function to say if it snows nothing at all, so 0, it would run across to 150. If it snows 1/10 of an inch, $180. And this is on a per day basis for the entire student population for the snow crew fleet. And these numbers were calculated based off of my experience working with snow crew, as well as just a rough calculation of the amount per hour the employees charge, as well as the amount of hours required to work to clear the snow. In this case, with 0 snowfall equating to $150, in my experience, even if snow isn't present, there's always some duties that need to be done, whether it be icing or clearing some areas. Over the winter months, there's always some people working with the snow crew. So from here, I ran an average of what it would cost per day, running about $200 per day. Then I multiplied that by the amount of days in the month. So for November, that would be 30, giving us around $6,000 that it would cost for the month. And I repeated this exact process for every month in the data I collected. So we have December, the exact same VLOOKUP function with the table. January, the exact cost and VLOOKUP function with the table, as well as ifs function for the cost per day. February, March, and April, all the same. All of the numbers being right around $200 a day. A little bit less in April as it snows a little bit less. And March the same. So with these data distributions I was able to get here, I found the cost per month forecasting out for the next snow season here with the best of my abilities. Thank you.